All right, hi year 11s, this is another special request on electron dot diagrams of polyatomic ions. I guess I'll make this video eventually next year, but we'll see how we go now. All right, so polyatomic ions are the common ones are going to be things like CO3 2 minus or NO3 1 minus or SO4 2 minus or even HPO4 2 minus. Okay, so these are some common polyatomic ions, more than one atom ions. All right, they have lots of oxygens on them. If you're talking about other polyatomic ions like Cn minus or NH4 plus, this video is not going to really help you. You can go Google search how to do those ones there. All right, so let's go through how to do some of these ones here. So let's go look at the steps. These are the steps that we've gone through in class. I'm not going to go read them out again. You can read. So let's have a look. So let's start with CO3 2 minus. We're going to add a hydrogen for each negative charge. So there are two negative charges, so it's going to turn out to be H2CO3. Okay, then we're going to look at the central atom. The central atom is going to be the carbon, so it's going to be the carbon in the center. We're going to add an OH group for every hydrogen. So there's two hydrogens, which means that we're going to need to add two OH groups. So those OH groups are a single bonded to the atom in the middle, and they're going to look something like this, like that. Okay, so two OH groups bonded to the central carbon. You put the remainder electrons on the central atom. So this carbon here it brought two electrons to the diagram, so it needs to bring two more. So that's that one and that one. All right, so now that you've got all of the electrons on the central atom, and I guess what you should really do is draw them in pairs. Okay, so now that you got that, you got to check how many electrons does this central atom have access to, and this carbon has access to 6. These 6 here, which means it still needs another 2 more. So with the extra oxygens, which there is only one of, it's going to put those. It's going to double bond with that oxygen because it needs 2 more electrons. So it's going to bond with this oxygen in a double bond so that now it has access to 8 electrons. Oops, not there, there. All right, so now it has access to 8 electrons there. That's how you put on those extra oxygens. Then you're going to remove those hydrogens, and then you're going to add the square brackets and add the charge. Okay, and there's your carbonate ion without, well, hopefully not the red parts and the blue parts. Okay, that's how you would draw it. Those are the steps. Let's go try another one. Let's see how fast we can go do all of these. Okay, so the next one is NO3 minus. Okay, so NO3 minus, let's go do that. I'm going to add a hydrogen for the one negative charge, so it's going to end up as HNO3, that's nitric acid. Put in a central atom, that's your nitrogen. You're going to add in how many OH groups? Just one. So that's going to go there. All right. You're going to put the remainder central electrons on the central atom. So this nitrogen would normally bring 5, and currently in the diagram it's only got 1. So you're going to have 4 extra. It's got access to, so we're going to put in these extra oxygens. This nitrogen has got access to 6 electrons, which means it needs another 2 more. So which means it's going to double bond with one of those oxygens to complete its 8. Right? So now the nitrogen has access to 8 electrons. Everything is happy. However, there's still one oxygen to put on in this particular diagram. All right? And so this extra oxygen will coordinately covalent bond, which means that it's going to use the 2 electrons that the nitrogen has just floating around, the non-bonding pair, right, for itself, and is not going to share any electrons with the nitrogen because that would bring it to too many, right? So that is how it would use the 2 in the middle, so it has 8, right? So that it has 8, but it doesn't provide any more to the nitrogen. All right, so what's next? Let's go get rid of this hydrogen. Then I got to put some square brackets in. Come on. Then I got to put some square brackets in, and there's your nitrate ion. Okay, I'm not even going to talk during the next one. I'm just going to draw, and you can follow along because talking is boring. Okay, 1, 2, 1, 2. Mr. Lin not talking? How odd. Oh, whereas Mr. Lim made the mistake here. Mr. Lim made the mistake of drawing this one out before drawing these ones out. Okay, because if I had drawn those ones out, I would have seen that the sulfur has already got all of the electrons it needs, and so therefore that top oxygen is also going to coordinate covalent bond. All right, so there's that one there, and then that's just going to draw the last one. Nope, that's not right. Yep, and then extra ones there. Then it's got 8, so therefore it's going to have this. Then just remember, don't get rid of all of your hydrogens because you're going to have to keep one of them there. And then 2 minus. Okay, so that's how long it should take you to draw an electron dot diagram of a polyatomic ion. All right, that's that. Adios.